Good morning, everyone. I'm Shotade Olusegun. In today's video, I want to tell you all you need to know about time. Time is highly invincible, and as a result of that, it is so difficult to decipher. And so we're going to dissect that and go deep into what time is for real. So basically, I define time as electromagnetic speed of relativistic scaling based on my research discovery, based on unification of quantum mechanics to classical mechanics. And so there is one thing about time. Time has two identities. There is one identity that time assumes when in relativistic scaling to energy, and there is another. So the other identity is the default identity of time, which is instancy. Time is instant. Don't be confused with this. I'm going to actually shed more light on that. Then when time is in relativistic scaling to energy, then it becomes continuous. Also, energy has two identities. Energy, by default nature, it has the identity of infinity. Infinity, energy is everywhere. But when energy is in relativistic, is in relationship with time, then it becomes discrete. So I'm going to shed more light on this concept. I want to dissect all that we need to know about time. Now, the relationship of time to energy is inverse. So when you look at that formula of everything, you are going to see this inverse relationship of time to energy. And that is what, brings about the nature of constancy. And the constancy is, something we have in the conservation or conservative law of the universe to prolong the effect, either to prolong the effect of expansion of the universe or to prolong the effect of, the decaying mechanism of the weak nuclear force, or to prolong the effect of contraction of the universe. So by having this inverse relationship of time to energy, then we can have what is known as we can have what is known as finite universe. So every entity in the universe has its own uh, uh, universe effect. Let me put it that way. So when we extrapolate that, we can get it at universal level in terms of what that object contributes to the universe. So basically, we can actually get the universal mechanism, or let me say, we can actually get the universe mechanism of every object and extrapolate that at universe level to get to know the contribution of such entity. So by dissecting, for instance, an electron, we can get the universe mechanism of that electron and extrapolate that. And so basically, by that we can get to know that our universe, even as vast as it is, will definitely be finite. You understand? So when you have the inverse relationship of time to energy like that, so the kickbacks of time's effect on that infinity natures of energy will definitely, converge energy to a finite mass worth. And once we have that, then we're not going to have that effect of infinity, and so we're going to have finite universe. So now I'm going to use time energy wave model, which is what we have here. So the title is All You Need to Know About Time. So I'm going to use this time energy wave model to actually illustrate, the visual representation of what time is all about. So we believe that time, many scientists believe that time is a mere illusion. They even believe that time is just a mere human's construct. So time is more than numbers. So time is an entity in the universe. It's a phenomenon in the universe. It's an entity that is quite invisible by the nature of its instancy. You understand? So we're going to actually dive deep into this, but before we do so, I want us to quickly look at the 4 things we can say about time. So the first one is time is defined as electromagnetic speed of relativistic scaling. That is when in relativistic scaling to energy. Then the second one, atomic clock standard. The frequency of radiation transition from high energy to low energy state, atomic nucleus to nucleus. That is what is being measured as atomic clock standard. So definitely, when you have the relativistic scaling of high energy state to low energy state, you have the atomic clock standard. So we're talking about the nature of time while in relativistic scaling to energy in this form. So the default state of time is instant. This instant nature is visible in the rate at which quantum entanglement transmits information. So we can see that instancy in quantum entanglement. Then the fourth one, which is the last one, is the instant nature of time defines the event arising of black holes and the present phase of humans' biological clock. So I will have to explain more what that is all about. Now, the first one, which is it defines the event horizon. By applying formula of everything, we get to know that the information of everything that enters into the black hole and even the past information of such object, we still have them at event horizon. So information is not lost, just as there is information paradox. So information is not lost. Then there is something I want you to know concerning black hole. You can get to have a glimpse of this static nature at event horizon by a situation where an object is approaching an event horizon. The outside observer will say that object has been static, and to that observer it will be static forever. But in real sense, the object has really entered into the black hole. So what happens is that the object itself, while entering into the black hole, will not experience any stop, any kind of delay. But outside observers, will see the object being static, and they are able to see that break in momentum. And by applying formula of everything, which is this formula, we're able to see that static nature at the region of event horizon. And so at that event horizon, we have what is known as spontaneous symmetry breaking. The trajectory of time, right from the classical realm down to the quantum realm, is not symmetric. So because it is asymmetric, then that annihilation of zeros has to be done manually. So we're going to actually dive deep into that by using this time energy wave model. So now here we have time's wave traveling inversely to energy wave. Now when you have, based on this relationship, then the instancy of time we'll be having kickback effect on the infinity effect of energy. And so that will eventually allow us to have finite formation, which is going to be in form of mass work. So the entirety, everything you need to know about universe is right here. And everything you need to know about classical mechanics and quantum mechanics is right here. So now, as we have this relationship, we have emergence. In the expanding phase, we have emergence of triangle. The triangle is equilateral triangle, so it models the constancy of light, which is towards the low energy state at quantum level, then the constancy of gravitational field, which is towards the low region at classical level. So now, why do we have constancy? Constancy is to prolong the effect of that expansion, and so we have conservation of energy, right, by having the constancy of light and constancy of gravity. Now, by the time we supply these electrons mass worth in this formula, in the place of this m and this n, we are going to have what is known as suspension value. So the mass worth of this weak conveying force will be suspended to the strong conveying force. So we have this as weak conveying force. So this So now, the value we're going to have will be 5.7 times 10 raised power 48. So now, what are we going to have at the extreme end of this constancy? By having the low energy state at the extreme end of the constancy, we're going to have convergence. So the convergence we have at the topmost of classical realm we serve as arbitrary suspension, then it's going to be arbitrary mass worth. So this region is the classical realm, while this is the quantum realm. So now, by having this, we can draw that line because we know the value is not negative. So it's going to be in the classical region. So it's going to be at angle 45. So we draw it up to that point of suspension. Now, we have this value, this particular, I call this wave amplitude. This wave amplitude value can be interpreted as mass worth because at the extreme end, there will be convergence of mass worth. So in a situation where you have no effect of times relativistic scaling to energy, there will be, or maybe at low energy state, there will be convergence of mass worth. So now, we're now going to annihilate the suspended zero. And by annihilating the suspended zero, we come straight down. So now, for us to annihilate zeros, suspended zeros, right from this arbitrary suspension, we're going to do that manually. And so I did that in my research publication. You can see that there. So because we're trying to bridge our instance at classical realm to quantum realm. So by doing that, by annihilating the zeros, we're going to have this particular value. But there is a issue. the thing is, we use this value to get this counterpart value. When you put this mass worth of electron in this formula of everything, you will get the classical counterpart, which is 2,277,250,000 kilograms. You get that. Now, for us to move from classical realm, which is this suspension, down to the quantum realm, it means that we are traversing the quantum realm the second time. So now we're not going to get the real actual mass worth of electron, because we realize that the worth that we have is beyond this suspension. Now you can see this value is smaller to this particular mass worth of electron. Now this mass worth of electron is supposed to be in between this value, which is the closest region to the zero, and then the farthest region to the zero. This value is supposed to be right in between. But we now get to realize that this particular value is really going to be outside the time energy wave model. It's going to be outside time energy wave model, in the sense that the electron that is being used in this trajectory to expand the time energy wave model, that electron spread over, it spread across the whole expanded region, and that is why we could have electromagnetic field. So now we can't actually pin down, we can't have this big mass worth in that region for the real electron. So the electron that we now have access to is the antimatter of real electron, which is the positron, and that is even outside the time energy wave model. So by the nature of this mass worth to travel back into the system, we get to know that it's a positron because it has positive charge. And so when it travels, it's more or less like there is a spring that pulls this positron of electron back into the system. And once that gets back into this tiny space, the size will be unstable, and then there will be radiation, radiation, and that will lead to further decay into the singularity of the future, or into the singularity of the black hole. So now what we have here, this positron, the moment time crosses this arbitrary boundary, it will convert the infinite sea of electron to the positron. And then the radiation that we're going to have at this region, when time breaks the arbitrary suspension, that radiation will cause the electron, which is going to be converted to be positron, to have positive charge. And so once the positron is injected into the system, then the whole circle is completed. So we're going to have a flipped triangle as the trajectory into the black hole. So now the thing is, the moment this positron gets to this suspension, it's going to close this line to have the complete triangle, which is complete equilateral triangle. So we have the constancy of light and then the constancy of gravitation right there. So now that is that about time. Now we can see that the inverse relationship of time to energy creates constancy. It even creates, because by the time we use the wave pattern to model it, it creates variation as well. And so time, when in relativistic scaling to energy, it becomes continuous. And when energy is in relativistic scaling to, is in relationship with time, is become discrete. So now that is that about time. Then another thing we need to know about time is that at this present phase, the time, there is a slight break in motion. And there is where we can have our reality. So now the reality of classical mechanics to quantum mechanics is that the real mass world of classical mechanics is right inside the arbitrary suspension. But the real mass world at quantum level is outside the arbitrary suspension. And that is why it is difficult for us to get to know the reality at quantum level. So there must be a spontaneous symmetry breaking before we could get access to positron or electron to have the proper particle acknowledgement at quantum level. So that is everything you need to know about time. And with this, I believe I have convinced you, not to confuse you. Yes, okay. Rather, I will say with this, that is that. So now you know that time is not a mere construct of our mind. And you know that time is far more beyond numbers. So even though you are going to say the time reading, you're going to categorize it as numbers, then it's going to be, the numbers will be encapsulated by the title of what time is all about. So time is an entity which is invincible by its instant nature. So now I believe this video is quite informative. If you like the video, don't hesitate to smash the like button. Then I'm going to put I'm going to put link to my published link to my research publication in the description below. You can click on that and explore the whole thing. So don't forget to subscribe to this channel so as to be notified for the subsequent uploads. And then make sure you share it with your friends who want it to travel as far as wide as possible, so that we can have the needed advancement in the science and technology. Thank you. God bless you.